the very last thing is you said.
So magnetic flux density is magnetic flux per unit area. Unit for magnetic flux will be Webers. Magnetic flux density will be Weber per meter square, which is also Tesla. Now, what happens
Sir,
if
could you
we
zoom out a
put
bit?
or
I
pass
joined
a
late.
current carrying conductor, if we pass a current carrying conductor through a magnetic field, what will happen then? What I'm about to do. Current carrying conductor in a magnetic field. Now, so this is a U-shaped magnet.
Sir,
Yes.
सर ऊपर जा सकते हैं?
You mean this? Can take a screenshot.
Yeah, okay, just give me. Yeah, okay, thank you.
So here is a U-shaped magnet. We use these magnets for a specific reason. In this case, because we have bent a bar magnet into a shape of U, you can see that we can now get a North Pole in front of a South Pole. So this way, we will have like this is the north side of a magnet, and there will be a south side of magnet right in front of one another. So why do we use U-shaped magnets? Because in this way, we can have north and south poles of magnet right in front of one another, providing a uniform magnetic field. Now here we have a copper conductor. This copper conductor is connected to an external circuit. This is a battery. There is an ammeter that can measure how much current we are passing through. There is what we say a variable resistor that can control the amount of current. And here we have. So this is a circuit that we use. So this is a copper rod. Now, question. When current is set in copper rod, it experiences a force. Question is, why? Now, have we studied this much about this topic that we can find out why there would be a force on the current carrying conductor that is when it is set in the in a magnetic field? Now, answer to this question is very simple, but yes, it might be new for some of you. Do you think this permanent magnet, the U-shaped magnet, has a magnetic field? I hope you all are saying yes, because it's
Yeah,
a
yeah.
magnet. It should have a magnetic field. And when there is a current set in the conductor, do you think a current carrying conductor will have its own magnetic field? We studied this yesterday, that when there is a current in a conductor, it will have its own
Yeah, it will have a
magnetic
magnetic
field.
field.
And we find out the direction of magnetic field. We discussed that we can find the direction of the magnetic field using right hand grip rule. Okay. So if we round our finger, like if we make our thumb go along the direction of the current, the round of the fingers will let us know about the direction of the magnetic field around the conductor. So we discussed that yesterday. Now, we are now extending this thing. If there is a magnetic field of the permanent magnet, and there is a magnetic field because of the current carrying conductor, what happens when we bring two magnetic fields close to one another? Answer is, they either attract or they repel. They interact with one another. So when magnetic fields interact with one another, there is either attraction or there is repulsion. So this is me forming this answer. Let me know if you understand that.
Okay, but Mr. I have a
Permanent,
question.
yes.
Okay. Uh, last lesson you said that at whenever a charge is moving, it has a magnetic field.
Yes.
Okay, and now since it is moving through a magnet, will the charge be like uh, will the charge in the wire become faster?
Actually, if anything, it might become slower. But uh, practically speaking, because the force that it will experience, it will be in the perpendicular direction, there will be no effect on the speed. I hope you understand that if force acts in the direction of the charge, it should speed up. If force acts
Yeah, yeah.
opposite to the direction of the charge, then it should slow down. But what if the force is acting perpendicular to the charge? Then it should not slow it down or make it go faster. Okay.
Okay.
Permanent magnetic field. So does the current carrying conductor. When two magnetic fields are close, they interact and exert force action or this is why the conductor experiences the force. Now, this is how I will write the answer for this question. Now, one, can we measure the size of force? How can we measure the size of force? Okay, we have to set apparatus like this.
So we could use a mass balance.
Yes, we will. Good. So what are we doing? We measuring force on current carrying conductor in a magnetic field. Okay, so I'm setting apparatus C. This is what I'm planning. This is the same U-shaped magnet. Mhm. For the easement, instead of making it round, I'm making it square. Now, this is a strong U-shaped magnet. I'm placing it on the top of an electronic balance. So this is an electronic balance. Okay. Now, so it is something like this. It shows a reading on a screen. So this is a strong, permanent electronic balance. A wire is passing through the magnet. We have a switch here, a variable resistor, an ammeter, and a power supply. Okay, so we have a power supply, and this is a direct current power supply. It is a DC power supply. Ammeter, variable resistor, switch S. Question. When switch S is closed, reading on electronic balance changes. Why? This is a 3-mark question. I have almost told you the answer of everything. But right now, I want you all to write down the answer and share it with me in WhatsApp very quickly, all of you. You have exactly 4 minutes to do that. When the current carrying conductor passes, the current carrying conductor is set between the magnet. It is not touching the magnet. Remember, and copper is not a magnetic material. If you put a piece of copper near a magnet, copper won't do it. Like magnet won't do anything to the copper. Copper will not do anything to the magnet because copper is not a magnetic material. It's a good conductor, but it's not a magnetic material. But once it has a current in it, because the current's magnetic field, they start interacting with one another. And this
So,
is what
Mr. It's going.
generates force between them. And because, sorry?
So okay. So it's going to have a magnetic field. So they're going to both interact with each other. So there's going to be a contact force.
Yes. Contact force means that how do you think electronic balance measures anything? Like you put something on it because of the weight, the plate on the top of the electronic balance gets compressed. And this is done because of the contact force that is generated because
So
of the weight of the object. If you
so this
change
is
that
where
contact
Newton's third
force,
law comes in.
yes, yes. No. Newton third law, as mentioned by another student in over here, that was that when magnet exerts force on conductor, then conductor exerts a force on magnet. If magnet pushes the conductor up, then conductor will push the magnet down.
Conductor pushes down.
Yes, if conductor pulls the magnet, if magnet pulls the conductor down, then conductor will pull the magnet up. So there is a push for a push, there is a pull for a pull. That is what Newton's third law. If magnet pushes the conductor up, conductor pushes the magnet down. If
Yeah, I
magnet
understand.
pulls the conductor down, conductor pulls the magnet up. In both cases, the contact force between the magnet and the electronic balance is supposed to change. And that is why the reading on the electronic balance should change. Okay, I'm leaving a question for you guys along with the diagram. Question is, once I am done
Sir,
writing question, you can take a screenshot. Yes.
sir, you said you'd give me 2 out of 3 in my answer. Yeah. So what should I've added to make it 3 out of 3?
Can you compare your answer with mine over here? You did not mention how changing how force between the conductor and the magnet will cause the reading on the electronic balance to change. Like why the reading will change? The reading will change because of the contact force between the magnet and the electronic balance is supposed to change. That part was missing in your answer.
Okay, fine. Thank you.
Okay? Now, how can we use this apparatus to measure magnitude of force on current carrying conductor in a magnetic field. It is a 5-mark question. I need the complete details. What quantities we need to measure and how can we find out the force that is acting on a current carrying conductor in a magnetic field. Okay.
Okay.
So we will resume from the same point tomorrow. Okay.
Okay, so assalamu alaikum. Have a nice day.
Mister, sir, can I just
Yes,
take a screenshot of the notes?
You want to take a screenshot?
Yes, because I haven't written anything. I just wrote the questions.
Okay, I will share the screenshot. I'm sharing it in the group right now.
Okay, thank you, sir.